Before any NLP model can understand text, it needs to break that text into smaller pieces. This process is called tokenization. It sounds simple, but the decisions you make here directly affect everything that comes after. In this episode, we go line by line through what tokenization is, how to do it in Python, and the challenges it introduces. Tokenization is the process of splitting a piece of text into smaller units called tokens. A token can be a word, a sentence, a subword, or even a single character, depending on the approach. This is always the first step in any NLP pipeline because models cannot work with raw text strings directly. They need structured, countable units. Tokens are the atomic pieces that every downstream step builds on. NLTK is one of the oldest and most widely used NLP libraries in Python. To use its tokenizer, we first download the punkt resource, which contains the pre-trained tokenization rules. The word tokenize function splits a string into individual word tokens. Notice that the period at the end is treated as its own token separate from the word fascinating. Punctuation is always separated because it carries its own meaning and should not be merged with the word it follows. Sentence tokenization splits a paragraph or document into individual sentences. The sentTokenize function from NLTK handles this. Here, we have 3 sentences separated by periods. NLTK correctly identifies each boundary and returns a list of 3 sentence strings. Sentence tokenization is used in tasks like summarization, where you need to work at the sentence level rather than the word level. It is also the first step in many document processing pipelines. spaCy is a faster and more feature-rich alternative to NLTK for production use. After loading the English language model, passing any text through the NLP object returns a doc. A doc is a processed object that contains not just tokens, but also rich linguistic information about each one. The POS underscore attribute gives the part of speech tag. The eStop attribute tells you whether the token is a stop word, meaning a common word like is or that, the, which often carries little meaning. Tokenization is not always straightforward. Contractions are a common challenge. The phrase I cannot splits into I, ca, and the fragment N''T. Different tokenizers handle this differently. Hyphenated words like state of the art can be treated as one token or multiple tokens depending on context. Emails and URLs are another issue. Here, the email address is split at the @ symbol, which may not be what you want. Understanding these edge cases helps you choose the right tokenizer for your specific task. Modern transformer models like BERT and GPT do not use simple word tokenization. They use Subword tokenization. The idea is to split rare or unknown words into smaller pieces that the model has already seen during training. The word unhappiness might be split into un and happiness. The word tokenization might become token and ization. This way, the model never encounters a completely unknown token. It can still reason about new words by combining familiar subword pieces. The most common algorithms for this are byte pair encoding, word piece used by BERT, and sentence piece used by many multilingual models. Every language model has a maximum number of tokens it can process at once. BERT has a limit of 512 tokens. GPT-4 supports up to 128,000 tokens. If your input exceeds the limit, the text gets cut off and the model loses context. Token count also directly affects the cost when using paid APIs, since most providers charge per token. Understanding how your tokenizer splits text helps you estimate costs and avoid unexpected truncation. You now understand tokenization, the first step in every NLP pipeline. You know the difference between word and sentence tokenization, how to use NLTK and spaCy, the challenges of contractions and URLs, and why modern models use subword tokenization. In the next episode, we cover text cleaning and preprocessing, where we remove the noise that gets in the way of a good model. If this helped you, subscribe so you do not miss the rest of the series.